don't have to tell me anymore, fish.
Okay.
It was a one-time thing.
All right. Last section in chapter 4, we're going to talk about dilations. Now, where do we normally hear that word?
Hospital.
Okay, what are they specifically referring to?
Like birth.
Oh, okay, not the direction I thought that was going, but yes, your eyes, right? Okay. Thank you for that. I mean, you're not wrong, but so normally we're talking about our eyes, right? When our eyes dilate, okay, what happens? Yeah, like bigger or smaller, okay? So same thing that's going to be happening here. Our scale factor is going to change, okay? So a dilation is another form of transformation in which a figure is enlarged or reduced. With respect to a fixed point called the center of dilation. The scale factor, which we call K, that's why they put that K there in parentheses, is used to multiply or reduce the length of the sides in a figure. All right? So, when K is greater than 1, we will have an enlargement. When K is less than 1, we'll have a reduction, which should make sense to us because if I multiply by 2, that's going to double my figure. If I multiply by 1/2, that's going to reduce my figure, okay? So who can tell me on example 1, this is an enlargement, what would be my scale factor here? 2. How do you know that, Austin?
Because all the numbers are times by 2.
Because I went from 4 to 8, 3 to 6, 5 to 10. So my scale factor here would be 2. All right, what about on example 2? Okay, but we're using multiplication, so we're multiplying by 1/2. Now, it's fine you're going to think automatically dividing by 2, but then you need to say what's the same as dividing by 2? Multiplying 1/2, okay? Because we went half of 4 is 2, half of 8 is 4, half of 12 is 6, okay? So every side length has to be multiplied by the same number. Yes? Always, yeah. So, like I said, when it looks like division, it's going to be a fractional answer. Okay? All right, let's look at an example here. Example 1 says, graph the dilation given that the scale factor is 1/3. So, is this going to be a reduction or an enlargement? A reduction, right? If it's a fraction that's less than 1, is it possible to have a fraction that is actually greater than 1? Yeah. Give me an example.
Improper fraction.
Like what?
3 over 2.
3/2. Okay? So just because you see a fraction doesn't automatically mean it's a reduction. Has to be a fraction less than 1. Now, can anyone tell me what my rule would be if I'm multiplying by 1/3? What would it be if I was adding 1/3?
Oh.
It would be plus 1/3. So what is it if I'm multiplying?
Oh. I'm confused.
1/3 what? Yeah, 1/3 x. Good, Jordy. If I'm multiplying, it's just 1/3 times x, 1/3 times y. Okay? So I'm taking 1/3 of each number. Now, the first thing I'm going to have to do is figure out what are my ordered pairs for Q, R, and S. Okay, so Austin, I want you to tell me Q, Symphony, R, Aixa, S.
6-3.
Okay. 12-3. 6-9. Okay, now here's the other thing I want us to just look at real quick. What is the length from Q to S? 6. What about from Q to R? Both of those lengths are 6, okay? Because we're going to look at that in just a second, how that's going to change, okay? So first, let's find Q prime, R prime, and S prime.
2, 1.
Wait, I'm kind of out of room. Hold on. Let me move this. Let me just fix this real quick. So essentially, we are multiplying by a third, but what would be an easier way to find your answer?
Cross multiply.
Well, not even that. What did we just say was the same as multiplying by a fraction? Just dividing, right? So what could I just divide each of those numbers by? Not 1/3, just 3, right? Dividing by 3 is the same as multiplying by 1/3. Because doesn't a fraction show division? Yes. So it doesn't make sense for us to multiply by 1, turn around and divide by 3. So we can just divide by 3. So what would Q prime give me? 2, 1. What about R prime? 4, 1. And S prime? 2, 3. Okay? Now, we're going to graph those real quick. 2, 1 is here for Q prime. 4, 1 for R prime. And 2, 3. Okay? And what is the length of each side, QS and QR? 2 units, right? Which should make sense because we took a third of 6 because the original length was 6, so we're down to 2. Okay? All right? Now, what if instead we graph a scale factor that has 3 halves, which is this what I was just talking about, a fraction, but it's an enlargement because it's greater than 1. Okay? So, what would be my rule here? Yeah, 3 halves times x, 3 halves times y. Now, we are on this using our original, right? So our original Q, R, and S stay the same. So 6, 3, 12, 3, and 6 and 9. Now, when we multiply by 3 halves, what I would tell you to do is, so like if I'm going to do 6 times 3 halves, I would do 6 times 3 and then take half of that number. So what is 6 times 3?
18.
What's half of 18? 9. Okay? 3 times 3? Half of 9? 4.5. Or we could say 4.5 here would be okay. All right. What about 3 times 12? 36. What's half of 36? 18. 3 times 3? Half of 9. Okay, just as a reminder, I'm taking this whole number times 3. So 6 times 3,
18.
and then half of 18. All right. 9 times 3,
27.
half of 27.
13.5.
13.5. Okay, then we're just graphing each of these points. Now, when we graph 4.5, we're just going to go up 4 and then halfway between 4 and 5, right? So we're going to 9, and then 4.5 would be here for Q double prime. Then we go 18 and 4.5 for R prime. And then we're at 9 and 13.5. Now, does anyone know the distance from S prime to Q prime and Q prime to R prime? How far is it from 9 to 18? 9. Same thing from 4.5 to 13.5, also 9. Okay? All right. Okay, let's look at the back page. Okay, so this is to find scale factor. Okay, to find scale factor, you take the image, which remember, image is the new one, pre-image is the one you start with, right? So image would be like prime over just regular. Okay, so like you might put A prime over A, if that helps you remember that. Now, it's the length. So if I'm trying to do that here, which side can I actually find the length of? There's only one. Well, easily, T and S, right? So what's the length of T prime to S prime? 10. What about T to S? 4. Okay, so all we're doing is counting the length. T prime to S prime is 10. From T to S is 4. Okay, and then we write that as a fraction. Which one goes on top?
No.
10. Why, Joss? Because it's prime, right? We always start with prime on top, the original on the bottom. So 10 over 4, which simplifies to 5 over 2. Okay, so our scale factor here, 5 over 2. All right, same idea with example 2. What side length would I look at here? TU, right? The one that is going along horizontal. Okay, so I would start with prime because that's what we're going on top. How far is it from T prime to U prime? 1. Okay, what about from T to U? 4. Can't simplify it, so my scale factor here is 1/4.
How do you know that's 1 if it's just half?
Where,
1/2 and 1/2.
yeah, because it's from half to half. Or, 8.5 to 9.5. And, truthfully, Joss, we don't know that 100%, but we're going to estimate that it is. Okay?
I thought we could.
Well, in this, I really don't love it. In this, you should, because here's the deal. When we're finding scale factor, like, they're not going to give you a number like 0.7. Okay? So, here it would be okay. All right, last one. You're using a magnifying glass that shows the image of an object as 6 times the object's actual size. Determine the length of the image seen through the magnifying glass, given that the actual size is 1.5 centimeters. Okay? So, anybody have thought? Let's first write down the things we know. Do we know the pre-image or the image?
Yeah.
Which one? We know the pre-image is 1.5. So if we're finding scale factor, where would that go?
Bottom.
On the bottom, right? 1.5. And we don't know the image, so we could call that what? X. But what do we know?
It's 6 times.
Yeah. Now, all of us can solve this, right? How do we solve this?
Times 1.5, that's the legs.
So that would give you 9 is equal to X. Okay?
Oh, yeah.
All right. Now, just like we've done this whole week, keep your notes out, right? Look at it as you go through your work. We'll be all right.